This is the fourth video and I'll be explaining elimination reactions. So again, we start with the reaction conditions. The condition is that this happens in saturated compounds. Okay, elimination. So to eliminate, to remove something completely. So we start with saturated compounds like alkanes and haloalkanes, and then we remove on two adjacent carbons. Adjacent, I mean something like if you wanna remove hydrogens in this compound, you can't remove that and that. You must remove between two adjacent carbons. So if you wanna remove from this one, you must remove on this one. Or basically, if you wanna remove from the first carbon, you must remove also on the second one. Just like the two adjacent things which are next to each other, we call them adjacent. Okay, so just make sure you don't make that mistake. And then on this one, we're going to use Zaitsev rule. Remember, in addition reactions we used Markov-Nikov rule. So this one says the major product will be the product with the double bond that has more highly substituted, which is more highly substituted. Okay, so I'm going to explain using examples. What does that mean? So the first elimination reaction we're going to discuss is the hydrohalogenation, which is the removal of a halogen and a hydrogen from a haloalkane. So example, okay, so this is dehydrohalogenation. So dehydrohalogen, D means removal of something. Okay, so I'm going to start with a haloalkane. In this example, I'm going to use 1-bromo ethane. So 2 carbons, 1 bromo, and then 2 hydrogens and 3 hydrogens. So let's check if we have reaction conditions. So we'll be using sodium hydroxide. This is a base to remove or to extract these atoms, and their reaction condition is that we need ethanol and heat. Okay, so don't forget those are the reaction. So if you are given these conditions, just know that this is the hydrohalogenation. Okay, so let's see how the product is going to form. So in this case, we're going to remove a hydrogen and a bromine. Okay, doesn't matter which hydrogen you remove, as long as if you remove bromine here on this carbon, on the other one you must remove the hydrogen. You can't remove bromine and hydrogen from one carbon. I hope you understand what I'm trying to say. Okay, so we're going to use sodium hydroxide for this extraction, which is Na bonded to OH. So let's see what. So elimination, we remove things completely, which means we must now make a plan for this bromine and hydrogen, what is going to happen to them. You can already see by removing those two elements, you're going to have to form a double bond to complete the number of bonds here. There's no other way, so this results in a double bond. So now you move from a saturated compound to an unsaturated compound, so that is a double bond. So from a 1-bromo alkane, now you end up with an alkane. Okay, so this is 1-bromo ethane. That will give you ethane. So now we need to make a plan what's going to happen with the Br and the hydrogen. So the Br will be bonded to the sodium, and obviously the hydrogen will be bonded to the OH. So it means our byproducts will be NaBr plus OH plus H will be H2O. This is very simple. Okay. Alright, so let's look at another example. Let's say I'm using a 2-bromo butane. So this one is going to show you how to use the Zaitsev rule. Okay. So let's see what's going to happen here. So 2-bromo butane, I'm going to draw it. We have 1, 2, 3, 4 carbons, and 1, 2, 3, and then at number 2 I have a bromo, then hydrogen, 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 like that. So you can use any base, sodium hydroxide or potassium hydroxide. So let me use again the same base, NaOH. So in this one you will see how to use the Zaitsev rule. Okay, so I'm going to show the two products which are going to form. There's two possibilities. Now this Br can go with this hydrogen, right? Or it can go with this hydrogen. So we can take from, obviously we must remove the halogen from this one. So we can remove we can remove the halogen from this carbon. Then the hydrogen must come to from the adjacent carbon, and then also we can take from this adjacent carbon. So it's two possibilities. So I'm going to show you how the rule works. So let's draw the first case. The first case, I have this, then this hydrogen is gone, so I'm going to form a double bond. The Br is gone, so the last one remains as it is. Okay, as carbon remains as it is, so I'm just going to make space here. So that is the first possibility. Then let's look at the second possibility. So again I have 4 carbons, but in this case I can extract from the first one, so it means the double bond will be here, the bromine is gone. Okay, and then I leave everything else as it is, everything else as it is. Okay, on the first possibility I left this hydrogen, this one will remain, that one will remain, so this one is removed, and on the second possibility this is removed, so everything else stays the same. So the rule says that the major product will be the one where the double bond has the most number of substituents. So let's see where is our double bond. On the first one, here is our double bond. How many substituents? 1, 2. And then in the other possibility, here is our double bond. It only has 1 substituent. So this one will be our major product. This one is not the major product. I hope you understand how you have to form. The other way that you can think about this kind of situation is that we always prefer like the secondary alkenes over primary alkenes, and so this one will be primary, this one is a secondary, and then if we have a tertiary, we'll prefer a tertiary one over the secondary one. Okay, so you can think about it that way. That is the hydrohalogenation. Okay, so I'm going to explain now dehydration, which is the removal of water. Okay, so number 2, I'm just gonna remove this stuff here. I just need some space. So dehydration, so in this case we'll be removing a hydrogen and an OH. Okay, so let's start. So dehydration, we'll be removing a hydrogen and an OH. So let's say here's my OH, so it means this one will come from an alcohol. So this is a prop 2 oil. Okay, so let's see what's going to happen on this one. So we're removing a hydrogen and a OH and a hydrogen. So it's either you remove on these ones or you can remove on the other one. In this case, you will still get the same alkene. So the first carbon, if I want to remove these ones, the first one will stay the same. The second one, the first hydrogen stays the same, but the OH is gone. So I will have a double bond here. Then the last carbon, the 2 hydrogens are still there, but the other hydrogen is gone, which explains the formation of this double bond. Okay, so what is going to happen with the H and OH? They are going to form water. So this one is very simple. So always, even in this case, if there was any other product which will form, write down all the possibilities and check which one is mostly substituted. Okay, so let's go to dehydrogenation, which is removal of hydrogens. Dehydrogenation. In the alkane, I can use ethane, 2 carbons, 6 hydrogens. Okay, so I must remove hydrogens from adjacent carbons. So the first one I'll be left with 2 hydrogens. The second one again 2 hydrogens, which explains the formation of a double bond. What happens to the 2 hydrogens? They will bond together to form H2. So on this one we have a catalyst, which is platinum, palladium and nickel. So don't forget those, it's very important. Then the last one, these are very simple. Okay, so the last one is called cracking. So to crack something is to break up something into smaller pieces. So you can think about it on that in that manner. I'm not saying if they ask you the definition of cracking you must say what I just said. No, I just said it so you can understand for yourself how you can remember it. So cracking is the breaking up of large molecules into smaller ones, as simple as that. So you must expect these kind of definitions from your examination. So let's do cracking. So you start up with large molecules, then you end up with smaller molecules. For example, here they gave an example and they used a pentane. Pentane, you have 5 which is a long chain. So the reason for this is because smaller chains are mostly useful than the longer chains, so they break them up into smaller useful chains. So pentane has 5 carbons, which is a very long chain. Then you can break it up into 2. This can form an ethene, then that can form a propane. So you want to form a short chain and alkane plus an alkene. So you're gonna form two things. You're gonna form two functional groups. You're gonna form an alkane and an alkene. So in this case, our alkene is gonna be ethene. So 2 double bonds, hydrogen, 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 and then the propene is 3 carbons. 1, 2, 3, 4, 5, 6, 7, 8. So you are not supposed, you're not allowed to change the number of carbons and the number of hydrogens. The same number of hydrogens you start with on the product, you must have the same number of hydrogens and the same number of carbons. So let's see how many hydrogens we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then confirm on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you just broke down that long chain into smaller chains, but it didn't change the composition. You still have 12 hydrogens and you still have 5 carbons. That is cracking.